Okay, guys, so when you graph the triangle, we should be putting 8, 10 all the way up here. So 8, 10 should go all the way to the top, and that's A. 1, 2 is here, and that's B. And then 8, 2 is here, and that was point C. So when we connect all of the points for our triangle, what kind of triangle does this make, guys? It's a right triangle. So let's look at part B then. I want you guys to use the Pythagorean theorem to determine the length of side AB. AB is the hypotenuse, so that's what we're looking for. So let's name it C. So in order to find C using the Pythagorean theorem, we need to figure out what the lengths of each of the legs are. So will you guys count the spaces between B and C and tell me what the length is? Whoever gets it first, just shout it out. 7. Do you all agree? Okay, what about AC? So find the length AC. 8? Everybody agree? Okay, so to put this in the Pythagorean theorem, I'm going to actually write out the Pythagorean theorem to start. So the Pythagorean theorem is A squared plus B squared equals C squared. A squared we determined was 7, so that's going to be 7 squared plus B squared, that's 8 squared, equals C squared. We're just going to do this together, guys. What is 7 squared? Plus what? 64 equals C squared. What's 49 plus 64 come out to? 113. So we get 113 equals C squared, and then what's our last step? Square root both sides. So the square root of 113 equals C, which is approximately 10.6. Okay, so the length of the hypotenuse AB is approximately 10.6. So here's what I want you guys to do right now. We're going to hold on to this for a second, and the next thing I want you all to do is translate triangle ABC 10 units to the left and call it triangle DEF. Okay? So here, what I want you guys to do right now is take that triangle ABC and translate it 10 units to the left and name it triangle DEF. Okay, guys, here's what my triangle DEF looks like. So I took point A and I translated it 10 units to the left and I called that one D. And then I took point B 10 units to the left and I called that one E. And then C 10 units to the left and I called that one F. Does everybody's triangle look just like that? Will you guys please make sure that you label it in the same way that I did? So because we have ABC labeled in this way, when we translate it and we rename it DEF, we need to make sure that we put those points, name those points in the same order, okay? So the next thing I want you guys to do is to give me the coordinates of each of those. So what is the coordinate of point D? -2, 10. And since we moved it to the left, what's the only coordinate that changed? The X or the Y? The X, right? And all we did was subtract 10. What about coordinate E? What are the coordinates of E? -9, +2. And what about F? -2, +2, right? Okay. So now looking at that, we're going to name, call each of these points something. So turn your page, get out your highlighter again, and let's highlight this. Corresponding sides are sides that have the same relative position in corresponding geometric figures. So corresponding sides are the sides that have the same relative position in corresponding geometric figures. That's why I wanted you guys to make sure that you labeled the triangle in the same order, because those sides are considered corresponding. So let's look at part 3. Triangle ABCD and triangle ABC and triangle DEF are the same size and the same shape. Do you guys agree? Okay, each side in ABC matches its corresponding side in triangle DEF. So go ahead and take a look back, or actually keep yours up, but look at mine. What is the corresponding side for AB? DE, right? What's the corresponding side for BC? EF. And what about AC? DF. So let's make a few statements about the different sides of triangle DEF. The part 3 wants us to, given what you know about the corresponding sides, predict the side lengths of the triangle. So let's do DE first. We found the measure of line AB, correct? This one right here. So what would be the measure of DE? The same, what was it? 10.6. So segment DE is going to be approximately 10.6. What about EF? What side does EF correspond to? BC. So what's going to be the length of EF? 7. So will you write that down? So the length of EF is 7. So then what's going to be the length of DF? 8. So I'm going to skip a couple of these and let's just compare the lengths. So part C wants us to compare the lengths and to write down the corresponding sides. So AC corresponds to which one? So look back at your original. What side does AC correspond to? DF. Okay, so then do BC for me and AB for me really quick. So we're just writing down the corresponding sides now. Okay, guys, so what's the corresponding side to BC? EF. And what's the corresponding side to AB? DE. Do you think that the order in which we list the coordinates or the different points matters? So could I also say that CA is congruent to DF? The measures are congruent, yes, but when we're talking about corresponding sides, it is very important that you put them in the same order. So when I'm talking about point A, the corresponding point to A is D, so I want you to list D first. Does that make sense? So when I say that what's the corresponding side to AC, I want you to list it in the same order, DF, okay? Because that is going to become important later when we're talking about angle measurements. So just get into the habit of doing them in the same order, okay? So what do we call this, or what can we conclude? Part 5. We can conclude that the corresponding sides of congruent triangles are congruent. So we can conclude that if two triangles are congruent, each of the corresponding sides are congruent to each other. And that's what we said here in Part C. Each of these corresponding sides are congruent. So now let's talk about the angles of these two congruent triangles. So number 6, we're going to use a protractor to determine the measures of angle A, angle B, and angle C. So what I want you guys to do is first write down the angles, and then we'll flip it over and we'll measure each of the different angles. So let's flip it back to our triangles, and we're going to do the different measures using your protractors. So let's find the measure of angle C first, which should be the easiest one for us. So remember, you line up your protractor on the measure, or on angle C. Make sure that segment BC is with a straight line going horizontally, and then we look at CA, and it goes all the way up to what number? 90. So the measure of angle C is how many degrees? 90 degrees. Okay. Let's do angle A. So angle A is this angle right here. So you can go one of two ways. You can flip your paper like this and line it up this way. Or you can flip it the other way, but you're going to get the same measure regardless. So angle A goes all the way out here to what number? 40. So the measure of angle A is 40 degrees. So will you guys measure angle B for me really quick? What did you guys get for the measure of angle B? 55? 50? Some said 50, some said 55. Okay, I'm going to line up, I'm not going to move my paper, I'm just going to line it up this way. So I put this line right on angle or point B, make sure it lines up, and then my line goes all the way out to 50. So I'm going to say 50. Which should make sense because all of the angles in a triangle should add up to what? Do you guys remember? 180. So 90 plus 40 gives us 130, plus 50 gives us 180. So you need to make sure that your angles measure to 180. So now let's take a look at this next definition. In each angle in triangle ABC corresponds to a specific angle in triangle DEF. Corresponding angles are angles that have the same relative position in corresponding geometric figures. So the next thing we're going to do, we're going to skip 7 and we're going to go all the way to 8C, and we're going to list the corresponding angles. So I want to find out which angle corresponds with angle A, which angle corresponds with angle B, and which angle corresponds with angle C. So using what we know, if the measure of angle C, so I'm going to go back over here, if the measure of angle C is 90 degrees, which angle measure in triangle DEF corresponds to angle C? Which one's also 90 degrees? This one right here, which is F. It looks like E, it's really F, because it goes DEF. So the measure of angle C is equal to the measure of angle F. So let's write that one. So I want you guys to find which angle corresponds to angle A and which angle corresponds to angle B. Guys, which angle corresponded to angle A? Which one? Angle D. Let's check it. So measure of angle A is this one right here, and so the corresponding angle would be angle D. So which angle corresponded then to angle B? Measure of angle E. Okay? So the order actually does make a difference here when you're listing the triangle. So I want you to make sure that you are aware of that. So then we can say, or we can conclude, that corresponding angles of congruent triangles are also congruent. So write that down for me. Okay, problem 2. Now I'm going to give you a congruent statement about two triangles, and we're going to list all the congruent parts and the congruent angles without graphing it at all. So look at number 1. Consider the congruent statement. Triangle RJRB is congruent to triangle MNS. Part A wants us to identify the congruent angles. So this is why I said that the order does make a difference. The order that we list the congruent triangles means that the corresponding parts in the same order are congruent. So here's what we would do. The congruent angles, we would say that angle J, because angle J is the first point that is listed, is congruent to what's the first angle that's listed in the other triangle? Angle M. So we can say that angle J is congruent to angle M. It will always be this way. So the congruent statements means that the order that I am writing them in are the parts that are congruent. So will you guys give me the congruent statement for angle R and angle B? Okay, guys, angle R is the second angle that's listed, so which angle is congruent to angle R? Angle N. So that means which angle is congruent to angle B? Angle S. Make sense? So the order does make a difference here. So let's talk about then part B, the congruent sides. This part is a little trickier. It's the same idea that the order that they are listed means that those parts are congruent. So we would say that segment JR, so let's do J to R first, is congruent to the next segment that's listed first, MN. So we would say is congruent to segment MN. The next segment that we can look at is going from point R to point B. So let's look at segment RB. Which segment is congruent to segment RB, guys? NS. So segment NS. Make sure you put the segment line above it. Now, triangles have three sides, so if we did JR and we did RB, what's the last segment that we're missing? JB. Which segment is congruent to JB? MS. Okay, does that make sense? So the order that the triangle points are listed means that those parts are congruent. So the order does make a difference. So the very last thing I want to go over with you guys really quick is how to do this with a picture, because this is going to show up on your homework as well. So let's look at these two triangles that are given to us in number 2. I have a triangle TWC, and then I have this triangle over here. So the first part we need to figure out is it looks like TWC might be congruent, but it was changed in some way. What transformation was used to change triangle TWC? 90-degree rotation. Which direction? Counterclockwise. So we say rotated 90 degrees counterclockwise. Sometimes they will just be shifted, so translated. Sometimes the triangles might be reflected, so you have to be able to tell what was done. In this one, we have our triangle, and then it looks like they rotated at 90 degrees counterclockwise. Okay? So now that we know that, just answer this out loud. We don't have to write it down. Does the transformation preserve size and shape of the triangle?
Yeah.
Yes, the rotation does not change the shape of the triangle. So what we're going to do next is we're going to write a triangle congruent statement. Triangle congruence means that we're telling you which parts of the triangle are congruent to each other. So we have to start with the original, triangle TWC. Okay? Is congruent. It really doesn't matter which point, what order you list the points in, just as long as when you write the congruent one, you do them in the same order. Okay? So looking at triangle TWC, which point corresponds to point T? Is it P, M, or K? P, because we took our triangle and we went this way. So we have to list triangle P, or point P first. Which point corresponds to W? M. And which one corresponds to C? K. So you have to list the points in the corresponding order. And then the last thing I want us to do before we leave is identify the congruent angles and the congruent sides. So we have angle T, angle W, and angle C is congruent, is congruent, is congruent. So do that for me. And then also the congruent sides. TW is congruent, segment WC is congruent, and segment TC is congruent. And then I'll let you check your answers. Angle P, angle M, angle K, PM, MK, and PK.